And from the syllabus, you can see that I put some information on the header of the syllabus. So you can see the course homepage and the book homepage and also the Facebook Q&A community. From the course homepage, you will see here. From the course homepage, you will see this page with the syllabus and the book homepage and the Facebook Q&A community. And also there's a 2-day short course which I gave in the summer, just last month, off campus. And they videotaped the course, the 2-day course, and it's in Chinese. Unfortunately, it's in Chinese, no, not in English. So if you want to take a quick look about the book content, you can go to see this. So if you go there, you will see you will need to download a prayer, and once you download the prayer, you can pray all the video there. Okay, and also you can download a slide, and so all the slide can be downloaded here from chapter 1 to chapter 8 and the appendix. Okay, so you got a slide in PowerPoint, and also the previous course page. And I have removed the solution to the previous old exam. I think I still leave the solution to the old exam, but I removed the solution to the exercise, so that if I give the same questions as last year, you wouldn't find a solution on internet. Okay, so the course announcement will be posted here. So if there are announcements, say homework number 1, homework number 2, the midterm, the final exam, I'll announce here. So in addition to the class, I'll put it here. Okay, so this is the course homepage. And in the syllabus, I mentioned that the course is a ordinary or a typical computer network course. However, the uniqueness is the book we use. And the uniqueness of the book is that it tries to bridge the design with the implementation. All the previous textbook, they focus on design only. So they will talk about the protocol design and the protocol behaviors. However, they do not talk about the system, the implementation. So even after you take the computer network course using those textbooks, you still don't know where and how a protocol could be implemented. So in my book, I try to tell you where and how a protocol is implemented, especially in the Linux system, so that you would know, okay, OSPF is actually implemented as a Linux daemon. It's a daemon process running there. And so that you know that table lookup is actually implemented in Linux kernel with an array of hash tables. Okay, and PPP, which is a protocol, point-to-point protocol, is implemented in the driver. Okay, in a Linux driver. And CSMA-CD and CSMA-CA are actually implemented in the hardware, the network interface card. in the hardware. So I try to tell you this, how this protocol, after explaining how the protocol is designed, how the protocol behave, I try to tell you the implementation in Linux system, so that you would bridge the gap between design and implementation. And knowing that the design and both design and implementation is important, because if you go to the industry, you definitely need to know the implementation, the system aspect. And if you go to the academia, if you come out a solution, an algorithm to improve something, then you don't want to simulate your design. You want to implement your design and test your design and see how your design behave. Okay, so that's the key point, the virtue or the beauty of knowing both design and implementation. And totally, there are 56 open source implementations that span across from hardware, as mentioned in the syllabus. In hardware, we talk about the modulation, line coding modulation, AB10B, which is line coding, OFDM, which is a modulation scheme, CRC32, which is an error detection mechanism, and CSMA-CD encryption and decryption. These are implemented in hardware. And some in driver, say the part of the Ethernet is in the driver, and most of the PPP are in the driver. And kernel, a whole bunch of protocol behaviors are implemented in kernel, including the table lookup, which is called longest prefix matching, and checksum, which is another error control, error detection, and NAT, network address translation, TCP, socket, shaper, scheduler, and the daemon. Some are implemented in as daemons. For example, the RIP, OSP, BGP. These are the routing protocols, and they are implemented as daemon processes. And DNS, domain name system, FTP, SMTP, PAP3, IMAP4. These are the mail protocol, and they are also implemented as daemon process. HTTP, which is the protocol for web, World Wide Web, SNMP for management, network management, SIP, SIP for VoIP, voice over IP, streaming, and peer-to-peer. So we'll look at these 56 open source implementation, which are interleaved with the protocol design behaviors. Okay. So they are not. We don't want to talk about the design first, and finish all the design and then talk about the implementation. We try to interleave them together, and the advantage of interleaving design and implementation together are that right after you see the design, you see the implementation immediately. That will give you a better chance to access the implementation. And these implementations are all open source programs that are freely available. So you can access this implementation right away. And compared to, if we have two book volumes, one for protocol design and one for protocol implementations, then the chance will be that you would only read the design, the first volume, and the chance that you will read the second volume will be much lower. Perhaps it's like in operating system. Most operating system course use some traditional textbook, And again, they don't touch the implementation. They don't touch the real systems. And if a department, a computer science department, wants to arrange a course that can give a better implementation exposure to operating system, then they would arrange a second course, the second course on operating system. However, the chance is that probably 100% of computer science students would take the computer operating system course, first course. But probably only 30% of the students would take the second course, which is on implementation. So then only 30% of the students will be exposed to the implementation. That's the first disadvantage. Second disadvantage is if you talk about the design in one semester and then the implementation in the second semester, then you already forget what the design issue already. So once you look at the implementation, you almost forget the design issue already. And looking at just the implementation does not make much sense to you when you have forgotten the design issues. So the best way is to interleave them together instead of separating them into 2 books or 2 volumes or 2 courses. So in just one course, we could do that by interleaving them together. So that's the approach of the book and also of this course. And in the book, as you can see that all the open source implementation are numbered. Okay, so for example, open source implementation 3.4 means in chapter 3, and there are say like 10 open source implementation, and 3.4 is the fourth one in chapter 3. Okay, then I'll move on to talk about the course outline that I put here, and it's from chapter 1 to chapter 8, and then 4 appendixes. And for chapter 1, it's fundamentals. And chapter 1, I start to receive some feedback from instructor, from some professor from other universities, and most of them are quite positive. They like chapter 1, and because chapter 1 convey a lot of basic ideas. Okay, so chapter 1, and some instructor, very strange, some instructor told me that something conveyed in chapter 1 probably are something they don't know before. Okay, they don't know because in chapter 1 I cover why the design philosophy behind the internet. Okay, some design philosophy for why we come out with a stateless, connectionless IP, and why how internet resolve the connectivity issue and scalability issue and resource sharing issue. So chapter 1 is compared to some other book. Chapter 1 is probably a little bit heavier because I try to convey, give an overview of basic ideas, and those basic ideas will be used later in throughout the book. So, but chapter 1 is not thick. It's only 55 pages or 53 pages. So it's not a thick chapter, but with a lot of interesting stuff, a lot of interesting idea, concepts conveyed there. and then at the end of chapter 1, there's a book roadmap, a package life. And some instructors like it very much because it gives you a very, it's like a tool that show you around where the packet will go inside the internet, inside a router, inside a server, and also inside the internet. Okay, and in chapter from chapter 2 to chapter 6, these are organized in the bottom-up fashion from the physical layer to the link layer and the IP in the network layer, or so-called IP layer, and then the transport layer, and then the application layer. Okay, so these are organized in the bottom-up approach. I know some, there's one book which is computer network in a top-down approach, and they organize into the top-down fashion from the application layer down through the physical layer. That organization might be more accessible to undergraduate students. But if you are a graduate student and you are supposed to design and develop a system, then you should know from the bottom up. It's like if you want to build something, you build from what? You want to build a building, where do you start? From a basement, right? So you start from the lower layer to the top layer. Okay. But if you try to, instead of building something, you try to learn something, probably you can start from the application layer down to the physical layer. Okay. But in that book, I found that they put much emphasis on application layer, but too little emphasis on the middle network transport layer, and almost no emphasis on the link and physical layer. Okay, so that's too heavy on the top, but too light on the bottom. But if you try to build something, you should learn from the bottom. And also, perhaps you will be a software engineer, so you probably would not touch the physical layer. But knowing the physical layer and also the link layer, what kind of methodology, what kind of implementation are there, could be helpful when you design the upper layer. Okay, so we start from the physical layer, and the physical layer we talk about mostly on the two important mechanisms, which are called coding and modulation. So coding and modulation are the two most important subjects in the physical layer. And and also in the physical layer, there's a section on advanced topics on advanced modulations, and the material here are quite new, because you probably it'll be difficult to find a book talk about the advanced modulation scheme like OFDM and MIMO, but here we put it into one section. Okay, and then up to the link layer, you will see one point-to-point link, which is called PPP, and then Ethernet. The several kind of broadcast link, including Ethernet and wireless links. And in wireless link, we talk about wireless LAN, Bluetooth, and WiMAX. And then we talk about the bridging and switching here, transparent bridging. And then at the end of the chapter 3, there's a section on device driver. And the chance that you would write a device driver will be very high. So this section is important, and it will tell you how a device driver works to move packet around, to move packet incoming or outgoing. Okay, in chapter 4, that'll be the core of the internet, which is the network layer, or the so-called IP layer. And here we talk about the data plane protocol, including IP and IPv6. And then we talk about the control plane protocol, including the address management, error reporting, routing, and multicasting. So the concept of data plane and control plane are covered in Chapter 1. Okay, so that's why I say Chapter 1 is important to start with. Okay, in Chapter 5, we talk about the transport layer. And there are two major protocols at the transport layer, including UDP and TCP. And we'll see how each works, and also why we need both. And when do we need TCP, and when do we need UDP. And on top of UDP, there's another protocol called RTP, Real-Time Transport Protocol. And that will be covered in one section, 5.5. And then we move on to Chapter 6. That'll be the application layer. And there'll be a whole bunch of applications to cover. I arranged them. I order them in the order of importance, and also in the order of classical and versus new application. And the most fundamental one will be DNS, domain name system, and then email, www, FTP, SNMP, voice over IP. And three new protocol or new application are voice over IP, streaming, and peer-to-peer. These three are considered as the emerging application. Some are getting very popular now. Some are still increasingly popular. And then that will be the cover all the layers. And you will find that for each chapter or for each layer, we start from the general issues. So in the general issue, we'll talk about the issue we need to resolve at this layer. And so it's a good start to start to look at a layer by looking at what issue you need to address here. Okay, so after Chapter 6, there will be two advanced chapters, or two chapters on advanced topics. Okay, one on Internet QoS, one on network security. Okay, Internet QoS is about making the Internet, service quality, controlling the service quality on the Internet. So you want to control the latency, the loss, the jitter. These are the performance metrics you want to control. And you want to divide the bandwidth. You want to share the bandwidth. Okay. So Internet QoS will be dealing with these kind of issues. And that's one chapter on it. And then on Chapter 8, we'll talk about the network security. From the data security issue that we will talk about virtual private network, and then asset security. We will talk about firewall, TCP/IP firewall, and application firewall, and then the emerging system security. We'll talk about intrusions, all kind of intrusions. Intrusion detections. Okay. So right now, network security is still an evolving issue. Still some space, some issue to resolve on data security, asset security, and system security. Okay, and we got 4 appendixes to look at. The Appendix A is about who is who. So here we talk about mostly histories. about IETF, about open source community, about other community, research community, and other standard communities. And at the end of Appendix A, there's a section on history. It covers the technologies that have faded away, meaning a technology that had been hot for a while, but didn't succeed. Okay, or they have been hot and succeed for a short while, but fade away, no longer existing today. Okay, so we talk about the history and explain why they failed. Okay, so that's in Appendix A. Appendix B, C, D are some background information I would strongly recommend that you look at. Appendix B will talk about Linux kernel overview. So we'll talk about the Linux source tree first. Okay, the source tree, and then the source code of networking. I would say that networking is probably one-fifth of Linux kernel. So networking code is about one-fifth of the entire Linux. The other part are process management, memory management, file system, and I/O management. And then the fifth part will be networking. So networking only accounts for one-fifth. And we'll talk about in B.2, in section B.2, we'll talk about where the networking source code are, under which directories. And there's a table showing what kind of mechanism are in which source code files, in .c source code file. And then we talk about the tool to trace source code. So we'll introduce a tool like LXR, C-scope, those kind of tools to trace the source code. And there's an example showing how you could trace the source code with the tool LXR. Okay, so if you are not familiar with Linux, especially Linux kernel, look at this appendix will help a lot. It's not thick, it's short, and it will bring you into this Linux world quickly. And Appendix C and D are, one is for development tools, and one is utility, network utility tool. So if you want to be a Linux developer, you would need to get familiar with those tools on programming, on debugging, on maintaining the source code, on providing the program, and embedding the program. Embedding meaning that you want to compile, and then finally you got an image file and put it into the flash for the embedded systems. Okay, so the end result is an image file that you would load onto the target machine. So these tools, probably you will know the programming tool, like the programming tool that you will edit the source code or trace the source code. And then you would use the debugging tool like GDB, which is the traditional one, but there are some others that you should get familiar with. Okay, so if you are not yet a Linux developer, probably you are a Windows developer, but not a Linux developer, and this appendix will get you into a Linux developer quickly. And then Appendix D is on utility, network utilities, and meaning that you use these tools to do experiment, not for development, but for the experiment. Experiment on name address translation, domain name and address translation, or IP address and MAC address translation. Probing, you want to probe the internet. Okay, you can probe you use path route or trace route or visual route to trace the path from A to B, and you want to measure the latency of each hop. So you can use those kind of probing tool, and you can also monitor the traffic. You sniff the traffic with say Wireshark. You can record the packet and then decode the packet and see the packet header and content. Okay, and there are benchmarking tools that you would test the system. Test the system. You generate packets and see how fast a system can handle your traffic. How much the throughput could be. So these are benchmarking tools. And then you have simulation and emulation tool that you want to simulate a network or simulate a network component. You would use something like NS2. And you probably want to emulate a network. You want to emulate with a PC, you want to emulate a network. So then you would use a NIST net to emulate the delay loss jitter on one PC. So on one PC, you can emulate an internet behavior in terms of delay loss jitter. Okay, and there's another section on hacking tool that you can use, say, Nessus, which is a tool to hack the system, to probe a server to see any vulnerabilities there. Okay, so Appendix D are all about experiments that you can do on the network. And Appendix C are on the development for developers. Okay, so after I finish chapter 1, so I'll start from chapter 1. After I finish chapter 1, I will look at appendix quickly, but not thoroughly, because I couldn't spend too much time on the appendix. But I just want to let you know what we have on appendix. Okay. And then, so chapter 1 and then appendix quickly, and then go back to chapter 2, 3, and 4. And at the end, we'll cover all chapter to chapter 8.